Imagine three stars locked in a gravitational dance. Their movements seem random, violent, and utterly unpredictable. For centuries, this cosmic puzzle, the three-body problem, has baffled scientists, inspired sci-fi, and revealed a terrifying truth. Our universe is fundamentally chaotic. Today, we'll break down why three celestial bodies break physics, how chaos theory was born from this problem, and why it matters for the future of space exploration. Let's dive in. What is the three-body problem? First, let's define the problem. The three-body problem asks, can we mathematically predict the motion of three massive objects interacting through gravity? It's for two bodies, like Earth and the Sun. Newton's laws give us perfect equations: elliptical orbits, eclipses time to the second. But add a third body, everything breaks. Tiny changes in starting positions or speeds lead to wildly different outcomes. It's like a game of cosmic roulette. Newton himself called this problem a question that made my head ache. And in 1889, Henri proved why. The three-body problem has no general solution. It's not about math being hard. It's about chaos being baked into the universe. The birth of chaos theory in the late 1800s. French mathematician Henri tried to win a prize by solving the three-body problem, but he stumbled into something bigger. He discovered that even tiny errors in measurement, like a planet's position being off by a millimeter, would snowball over time, making predictions impossible. He called this deterministic chaos. Think of it like weather forecasting. Small changes in wind or temperature today can mean the difference between sunshine and a hurricane next week. The three-body problem taught us that chaos is everywhere, from dripping faucets to stock markets. Failure birthed chaos theory and humbled science forever. Real-world three-body chaos isn't just theory, it's happening right now in our galaxy. Take Alpha Centauri, the closest star system to Earth. It has three stars, A, B, and Proxima Centauri. Their gravitational tug-of-war flings planets into unstable orbits. If humans ever colonize there, we'd need to master chaos math just to survive. Key examples: exoplanet HD 131,399 AB, a planet with three suns where seasons last centuries. Black hole triplets. When three black holes collide, they warp space-time itself. 8. Solar system's fate. In 4 billion years, the Milky Way and Andromeda will collide. A galactic-scale three-body problem. Even Earth isn't safe. Mars' moon Phobos is spiraling toward the planet, doomed to shatter into rings. Why? Three-body interactions with Mars and the Sun? How scientists solve the unsolvable life? The three-body problem is unsolvable. How do we navigate space? The answer: approximations. Supercomputers crunch billions of scenarios to find stable-ish orbits. For example, NASA's Lucy mission to Jupiter's Trojan asteroids relies on these chaotic calculations. The Lagrange points, cosmic parking spots where gravity balances out. AI predictions, machine learning models now simulate three-body chaos faster than ever. But they're still guessing. And let's not forget sci-fi. In Liu Cixin's The Three-Body Problem, aliens exploit chaos to invade Earth. Could real extraterrestrials do the same? It's probably not, but the science behind it is eerily accurate. The three-body problem reminds us that the universe isn't a clockwork machine, it's a chaotic masterpiece. We'll never fully predict it, but that's what makes exploration thrilling. If you enjoyed this deep dive, hit like, subscribe, and let me know in the comments. Should we risk colonizing chaotic star systems? Thanks for watching, and stay curious.